Hi and welcome to this prediction for the Edexcel GCSE Maths Foundation November 2020 paper. Enjoy! Hi and welcome to this onmaths prediction for the Maths GCSE November 2020 series. So this is a really strange year, as I'm sure you're aware, that we haven't had a GCSE paper in the summer. This paper will be the first GCSE paper almost all of you will have sat, with the exception being Year 13 students who are resitting the Maths GCSE. So it's really, really important that you are prepared, both in your knowledge of the subject and just to your knowledge about how the exam works. And this is what this prediction is supposed to be used for. Please don't 100% rely on this prediction. First of all, the accuracy has been good in the past, but it's never 100%. There's always topics that are not predicted that come up in the actual paper. So make sure you do your revision. What some students do is they do this test now, see how far they can go with it, go off and revise, and then do the test later on to see whether they've improved their marks. And the way they can do that is, you can do it too, is if you go to onmaths.com, you can try this paper online for free. The numbers change each time, so you're not just remembering answers, you actually have to work them out. And it will give you a grade as you go along on the paper, just like this video. So you'll see exactly what grade you are at each point of the paper. We've got loads and loads of other stuff on the website. I'm not going to go into it, but there's loads and loads of stuff that you can also do. And if you click up here, which I think is there, it will take you straight through to the correct paper, so you can just get started straight away. If you want to sit back and just watch how to do the questions, feel free. If you want to give that a go first and then come back to this video, there's a link to this video in the actual GCSE paper on our site. Without further ado, I should say everything is completely free. You are not charged for anything on onmaths.com. So, let's get started. Okay, it's really important for the GCSE that you understand the two-dimensional and three-dimensional names of shapes. So this one is a cylinder, but there's no way of working out without just sitting and learning them. And there's some great posters out there and some great revision resources that just go through the names of the shapes. So this question's asking us to convert worded numbers into just numbers. So it says 2,605. So when we're thinking about numbers, we think about what column each of the digits are in. So we have our units column here, we have our tens column here, we have our hundreds here, and we have our thousands here. So we have 2,000, so I can put a 2 in here, 600. Now, it doesn't say any tens. If it said 35, I could put a 3 in the tens column, but there's no tens in that number, so I'm just going to put a 0, and 5. Now when you look at that number, you think, oh, that's 2,605, and that's what it says in the question. So that's our answer. Mode just means most common, so when you're asked for the mode for a list of numbers, you just write down the one that comes up the most. Now, most of you will recognise this straight away, but something that might help is putting them in order of size, because sometimes you can spot the mode a little bit easier, and you can see here that 7 comes up the most. You don't need to put them in order of size, but sometimes it can help. So the mode is 7. So for this question, you just kind of got to imagine what the shape will look like when it's finished. And the thing that's stopping it from looking perfect is not having this square here. And let's just check it has 4 lines of symmetry when I put that in. So we've got one there, we've got one across here, then we have a diagonal one here, and then we've got another diagonal one here. So it has 4 lines of symmetry. So it asks for an even cube number.
So the cube numbers are 1 cubed is 1 times 1 times 1, which is 1. The problem is that that is an odd number, so let's try 2 cubed. Now 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 8 is an even cube number. Now you could have also had 64, which is 4 cubed. 6 cubed is above 100, so that would not count. So 8 or 64 are the correct answers.
The first thing to look at with a pictogram, which this is the key. Now the key tells us what each picture represents. So if you have a look at the key here, it says each circle represents 8 DVDs. Now that's the complete circle. So it says what day are the most DVDs sold, Monday, Tuesday or Wednesday? Well, or you can always just look at which has the most shapes. Now Tuesday has 2, Wednesday has 1.5, but Monday has over 2, 2 3/4. So it's definitely going to be Monday because it's got the most circles. Now, how many DVDs were sold on Tuesday? Well, if each circle represents 8, there's 8 there and there's 8 there. So we just need to add the 8s together, which makes 16. So 16 DVDs were sold on Tuesday. It says how many DVDs were sold on Monday? Well, you've got the 8 there and you've got the 8 there. Now we've got a bit of a problem here because it's not a complete 8. So we need to figure out how much each quarter is worth. Well, what do you times by 4 to get 8? Well, 2. Let's check to see if that works. So we've got 2 there, 2 there, 2 there, and an extra 2, which is actually missing on that one, would make 8. So that would work perfectly. So to find out a quarter of it, we just divide it by 4, which gives us 2. So we've got the 8s, because we've got 2 complete circles, and then we've got those 3 2s, so we've got another 6. So we just need to add on 6 to the 16. So 16 plus 6 is going to be 22. So that's going to be 22. Okay, let's have a look at the next question. On Thursday, 20 DVDs were sold. Show this information on a pictogram. So let's have a think how many circles that will be. So if I've put one circle down, that's 8. Well, we've still got enough left over. If I put another full circle down, that's 16. Now 16, let's try another one. Let's put another full circle down, and that gives us 24. So that would be too much. So we're going to have to go into those quarters. So we've got 16. How many more 2s do we need? So 16, that would give us 18, and that would give us 20. So we need 2 whole circles and then 2 quarters. So if I shade in, if I draw, then shade in, 2 whole circles, and then we've got 2 quarters left over, which is just a half. Let's just check that. What's half of 8? That would be 4. And what's 8 plus 8 plus 4? That gives us 20. So we know the answer is correct. Okay, so we're asked to solve, which means find out what x is. So I'm going to put my lines in. Now on the left hand side here, we've got 12x. Now that is a times 12. Okay, anytime you have a number next to a letter, it's timesing it. So to get rid of that, which we need to, because we want x equals, we need to do the opposite of 12 times 12. So the inverse operation of times 12. The opposite of times 12 is divided by 12. And we have to do it to both sides to keep the equation balanced. So we're left with x on the left hand side, and we're doing 36 divided by 12, which is 3. So x equals 3. And we can check that by putting it into the original equation. 12 times 3 is 36. So that is correct. So for this question, we're asked to find the percentage of the shape that's shaded. So there are 4 sections in total, and 2 of them are shaded. So as a fraction, that would be 2 over 4. Well, we can halve top and bottom, so it's a half. And you can see there that half of that's shaded. So what is half as a percentage? Well, a whole as a percentage is 100%. So a half as a percentage is 50%. And if you didn't know that, you need to just practice knowing the main percentages. A tenth is 10%, a hundredth is 1%, and a quarter is 25%. Okay, the next question says what fraction is shaded. So we need to know two things. First of all, how many squares are shaded. So 1, 2, 3. So it'd be 3 over the total amount of squares. So there's 1, 2, 3, 4, 5, 6, 7, 8 squares. So the fraction is 3 over 8. For the next question, it says shade in a fifth of this shape. Well, there's 10 squares altogether, and we want to shade a fifth. So we need to find a fifth of 10. In other words, what's a fifth times 10? When you times something by a fraction, just divide it by the bottom of the fraction. So another way of writing that is 10 divided by 5, which is 2. A different way of thinking about this question is if you cut this shape up into 5 equal sections, those sections, the green sections, become a fifth. So if we want to shade 1/5, we just want to shade in one of those sections. And actually that's the amount of squares that our calculation just worked out. So it should be 2 squares. Now it doesn't have to be the 2 squares that I've shaded. As long as you've shaded in 2 squares, then you've answered the question. And the last question says write down the fractions there that are equivalent to a quarter. Well, a nice easy way of starting this question off is just write down things that are equivalent to a quarter. So what I'm going to do is I'm going to times top and bottom of this fraction by 2. So 2 over 8. So I've times them by 2. Then I'm going to times them by 3. So it would be 3 over 12. Then I'm going to times them both by 4. And I'm just looking at this original fraction here. I'm going to times them both by 4. So it would be 4 over 16. And times them both by 5. 5 over 20. Now all those fractions are equivalent, which means the same as a quarter. So let's have a look at our list. Well, we've got 2 over 8 there. So it's that one. And we've got 5 over 20 there. So my answer is going to be fraction B and fraction C. So to convert a percentage into a fraction, you just need to remember that percent means per 100. So that percentage sign there just means per 100. So it's 30 per 100 or 30 over 100. Then we need to simplify that. So we're going to divide top and bottom by 10 and we get 3 over 10. So the simplest version is 3 over 10. Now for this next question, we need to convert these all into the same thing. By far the easiest thing to convert them all into is percentages. So we don't need to do anything with C. For A, all you need to do is times it by 100. Any decimal, you just times by 100, it makes it a percentage. So that's 49%. Now with this one, we make it so that the bottom is 100. So what I'm going to do is times top and bottom by 20. And then as I said in the question A, percent just means per 100. So that's just 20%. And the last one is just 71%. It's already in percentage. Now you can clearly see here that the 20% is the smallest, 71% is the largest. However, we need to work out which way around it wants it. Where it says ascending order, ascending means going from smallest to biggest. A plane ascends when it takes off, and then descends when it starts coming down to land. So it's really important that you write in the numbers in the question rather than the ones that we wrote. So we're going to start with the smallest, which is 20%, which was 1/5. So don't write 20%. Then 49%, which is 0.49. And then finally 71%. Okay, so this question's about coordinates, and the biggest mistakes with coordinates is getting them the wrong way around. So point A, which is this one here,
it's either going to be 2, 1 or 1, 2. And the way of remembering it is you always go across first and then up. You go along the corridor, up the stairs. Okay, so you always read off the x-axis and then the y-axis. So the coordinate is 2 because we go 2 to the right from the middle, and 1 because we go 1 up. Now coordinate B is the same, so we're going along the corridor to -2, and then up 3. So along 2, or we'll go to the left 2, and up 3. Okay, it's asked us for which coordinate is at a point -2, -3. So we're going across to -2 again, but this time we're going -3, which means down 3. So it's going to be coordinate C, because C is at -2, -3. Okay, so we're asked which 2 points on the line y equals -2. So we've got to understand what y equals -2 is first. Y equals -2 is a line where y is always -2. Well, we know y is -2 here, but also y is -2 here, and actually anywhere across this line. And we call that line y equals -2 because y is always -2 along it. If you have a y equals line, it'll always go from left to right. If you have an x equals line, it'll always go from top to bottom. So the two coordinates on that line are D and E. So the 2 points on the line are D and E. So BidMath tells us we've got to do the brackets first, so we're doing the 11 squared minus 21 first, but we've got to do the indices before we do the subtraction. So we're going to do 11 squared first, which is going to be 121, and I'm going to write out the whole calculation to show that I've done that bit. Then I'm going to do the brackets, so 121 take away 21, which is just going to be 100. And then finally the multiplication, 100 times 3 is 300. Okay, so with this question there are quite a few steps we've got to go through. So it gives us some information about the parallelogram, that the area is 3 times the area of the triangle. So it looks like the place to start is the area of the triangle. So we're going to start off with the area of the triangle, and it's really important for these types of questions to be really clear to the examiner what you're trying to work out. So the area is half times the base times the height. So it's half times 8. I was going to write 6 there, but let's keep it in the same order. Let's tidy up that 8 a little bit. Okay, so half of 8 is 4, times 6 is 24, or we could do 8 times 6, which is 48, and then half of that. Either way you get 24. Okay, so we know that the area of this is 24 centimeters squared. And we know that the parallelogram is 3 times the area of the triangle. So the area of parallelogram equals 24, which is the area of the triangle, times by 3. Now I know 25 times 3 is 75, so I'm going to take away 3 from that, it's 72. So equals 72 centimeters squared. Now, I know that the height of it is 12, and I know to work out the area of a parallelogram, it is just base times height. And I know that the height is 12, and I know the area of it 72. So I just need to solve this. Quite an easy one to solve, because I'm just going to divide by 12. So the base is going to be 72 divided by 12, which is 6. So it's going to be 6 centimeters. Now we can work that out and just work backwards. So if this x here is 6, 6 times 12 is 72. Then I could do 72 divided by 3, which is 24. And 24 is the area of the triangle. So you kind of know you've got the right answer because you can work backwards with it. Okay, so for this question, the first thing we're going to do is we're actually going to convert these into easier numbers to deal with. So I'm going to times this left hand one by 10 and times this right hand one by 10. So we actually end up with whole numbers, which are much easier to multiply. I've just got to remember to turn them back at the end, to deal with that at the end. So there's multiple ways you can multiply these together. You can use the grid or column, or whatever method you feel comfortable using. So let's put these in a column. But again, there's no additional marks if you do one way or the other. Okay, so 5 times 3 is 15. Carry the 1. 5 times 1 is 5. Add the 1 is 6. 5 times 7 is 35. So it'll be 35. Now the next thing we're doing is 40 times 3. So what we're going to do is just add a 0 here, and then we can just think of it as a 4. So 4 times 3 is 12. 4 times 1 is 4. Add the 1 is 5. And 4 times 7 is 28. Then we're going to add going downwards, so 5, 6 times 2 is 8, 5 times 5 is 10, so it would be 8 plus 3, which is 11, plus the 1 is 12, and then 2 plus the 1 we carried, which is 3. So this is going to equal 32,085, but the problem is we times two numbers by 10, so we need to undo that. And we do that, undo it by dividing it by 10 and then dividing it by 10 again. So in total we've divided it by 100. So it's going to be 32 with a 0 and then 0.85. So the answer is 320.85. And normally you can just check to see roughly whether that's right. So 71 is roughly 70, 4.5 is, I don't know, roughly 5. So 7 times 5 is 35, so 70 times 5 is 350. Well, 320.85 is not far off 350, so we know we've probably got it right.
Okay, so first thing, whenever we're asked to solve, always put the lines in. So first thing we need to do is expand this bracket. So we need to times everything in the bracket by the 3 on the outside. So 3 times 6x is 18x. 3 times 12 is 36, equals 234. Next we need to get rid of that 36, so we're going to take away 36 from both sides. Okay, so we're doing 234 take away 36, which is 198, so 18x equals 198. And then we're going to divide by 18 on both sides, because that's a times 18 on the left hand side, so we're going to divide that by 18. And x equals 11. And we could feed that into the original equation, so 6 times 11 plus 12, then times it by 3, that should be 234. There is a different way of doing this. You could have divided by 3 at the first step to get rid of the bracket, and that's absolutely fine as well. Okay, so in this question we're on a school trip, and it's best to break this question down into bits we need to work out. So it says 4 buses each carry 105 students. So the first thing I need to work out is how many students there are in total. It says 35% of the students are bringing their own lunch, so we don't need to worry too much about those students. A seventh of the students are buying lunch when they get to the theme park, and the question just basically says how many have not made plans for lunch. Okay, so find out how many students have not made plans for lunch. So they're not bringing their own lunch and they're not planning to buy lunch there. So let's do the first thing first, and let's work out the total total amount of students, and show the examiner what you're working out each time. So we're going to do 105 times by 4. You can do that any method you want, but it's going to be 100 times 4 is 400, 5 times 4 is 20, so it's going to be 420 students. So we've got 420 students in total. So next we need to work out how many are bringing their own lunch. So bringing lunch. Okay, so to do this, we're going to work out 10% first, which is going to be 42. Because if 100% is 420, that's how many students we have. 10% is, you just divide it by 10. And next we can work out 5%, which is going to be half of that, so it's just going to be 21. Next we need to work out 30%, because we need 35%,
And all we do is times the 10% by 3. And again, I could do a bit of working out for this. So 42 times by 3. And you can use any method you want. A lot of you probably prefer doing the grid, which is absolutely fine. So 40 and 2 and 3. Obviously, if it's on the calculator paper, you can obviously just use a calculator. But either way, you get 126. So it's going to be 126. Now 35 would be these two added together. So it's going to be these two added together, because 5 plus 30 is 35. So 35% is going to be, and I can do a bit of working out here, so 126 plus 21, or the other way around, 741, so 147. Okay, so 147 students are bringing lunch. Next, so buying at park. So students who are buying at the theme park. It says a seventh of the students. So to find a seventh, all we do is we get the amount of students, which is 420, and we just divide it by 7. And again, you can do this any way you feel comfortable doing, although this is a bit easy because 42 divided by 7 we know is going to be 6. So 7s into 4 don't go, so carry that on. 7s into 42 are 6, 7s into 0 are 0. So it's going to be 60. So students left. So we're going to do the amount of students, which is 420, take away the people who are bringing lunch, plus the people who are buying it in the park. So we need to work out what that is. So it's 147 plus 60. So 7 plus 0 is 7. That's going to be 10. And so that's going to be 207. And finally we need to work that out. So 420 take away 207. So you can't do 0 take away 7, so we nick 1 there. 10 take away 7 is 3. We need to nick 1 there as well. So 11 take away 0. Oh no, I don't need to nick 1 there, do I? So we've just got 1, so that's 1. 4 take away 2 is 2. So the answer is 213. Now it's really important that you set your work out really logically. Any working out you do, try and keep it near where you've done done the calculation, written the calculation down. So I'd probably put this down here if I had like a piece of paper in front of me. Obviously I've moved these around slightly just to make them a bit clearer, so I'm not constantly scrolling. The headings are really helpful. So as an examiner, if you headed all of your working out, it's really easy to spot what you've done and give you credit for it. So just make sure you set out your working out neatly and logically. I always find it easier with these questions just to do a simple sum first. So I'm going to do 2 times 3 equals 6. And I'm going to think how I can rewrite this. Well, I can put the 6 here, divide it by the 2, and that gets me the 3. So it's just a matter of moving the answer to the start and picking one of these guys to divide it by, and then we get the other one. In this question we have exactly the same thing. So what I like to do first of all is just rearrange the fact that I'm given. So I'm going to put the 2376 first, then we're going to divide by the 99, and I know that that will get me 24 if I did that. Now we've got to think about what we're doing in the actual question that it's given us. Well, we've times the top by 1,000 and we've times the bottom by 100. Now when we times the top by 1,000 it will make the answer 1,000 times bigger, but when you're dividing it's basically the same as a fraction. Whenever you times the bottom by 100, say, which we have in this question, it actually makes the answer 100 times smaller. So we're making it 1,000 times bigger and then 100 times smaller. So what are we doing in total? So one way of doing this is just to split that 1,000 up by times 10 times 10 times 10, and 100 times 10 times 10. So This times 10 will cancel. This times 10 will cancel. And we're just left with an answer that is 10 times bigger. So we've got the answer of 24 with a 0 on the end of it. Now, what might be easier is to think of that in terms of divided by 10. When it's at the bottom of a fraction, or you're dividing it by the number, it just becomes a divide by 10. So the answer is 240. Okay, so to do front elevations, we pretend that we are standing at the front, and this is my really bad picture of a person, and we need to draw down to scale exactly what we see. So we are not going to see, any of this. No, not going to see any of that. We're not going to see any of that either. So the only thing we're going to see is this bit here. And it's really important for front side elevations and plans that we don't have any 3D in the shape at all. So what's the width of that going to look like? Well, it's going to be 2 centimeters across. What's the height of it going to look like? Well, the height of that, shaded in blue, is going to be 6 centimeters. So when we draw this in, we need it to be a 2 across and 6 down, 1, 2, 3, 4, 5, 6 rectangle, like that. So no 3D added in, you don't show the slope at all. That's exactly how we'll show the shape. Whenever you're multiplying, subtracting or dividing with fractions, you must always convert them into improper fractions if they're mixed numbers. So here we've got two mixed numbers. We've got 6.5 and we've got 4 1/3. So we need to convert these into what we call improper fractions, top-heavy fractions. And we do that by timesing the big number by the bottom number, then adding it to the top. And we do that for both of these. So I'm going to do 6 times 2, which is 12, plus the 1 at the top, which is 13. And it's going to be over 2. Then I'm going to do 4 times 3, which is 12, add to the top, which is going to be also 13, this time over 3. Now, when the denominators are different, when we add or subtract, we've got to get the denominators the same. So I look at this fraction here, and what am I going to times top and bottom by to get it the same as this one? We're looking at the bottoms. We've got 2 and a 3, so we've got to find the first number in the 2 and the 3 times table, which is going to be 6. So we're going to times top and bottom here by 3 to get that 2 to a 6. We're going to times top and bottom here by 2 to get that bottom to a 6. So 13 times 3 is going to be 39 over 6. And 13 times 2 is going to be 26. And then 3 times 2 is 6. Now we just simply subtract the tops, which is going to be 13, and then put it over the same denominators we've had in the two fractions there, so it's going to be over 6. So we need to make it a mixed number in its simplest form. So we ask ourselves, how many 6s can I take away from 13? Well, I can take away 2 whole ones. How many remainders do I have left? Well, 6 times 2 is 12, so it's going to be 1 remainder, and the bottom of the fraction stays the same. So it's going to be 2 and 1/6. For this second question, we need to convert these into top-heavy fractions or improper fractions, like we did before. So 5 times the 4 is 20, add to the top 21 over 4. And 3 times 3 is 9, add to the top is 10, keep the bottom the same. Now here we have this 3-letter acronym, which for some reason all the students remember. It's KFC. I have no idea why people remember that. So what KFC stands for is keep, flip, change. Some students remember it as KCF or same, change, flip. Whatever works for you, stick with it. So we've got 21 over 4. Keep that the same. change the divide sign to a times, because you can't really divide with fractions, so we change it to a times. But to do that, we need to flip the second one, so it becomes 3 over 10. Now, what we're going to do now is we just simply times the tops and times the bottoms, and that's all we've got to do. So it's going to be 63 over 40. So again, we want to leave it as a mixed number. So how many 40s can I take away from 63? Well, 1. And when I do that, I'm left with 23 over 40. Now 23 is a prime number, so unless 23 goes into 40, which it doesn't, that is our simplest form.
Okay, so we're asked to factorise, which means put this into brackets. So the first thing I would do is put a set of brackets down. It's a quadratic because there's an x squared, an x, and a number term. So I'm always going to put 2 sets of brackets. And because it says x squared there, and there's no number before it, the first 2 terms are going to be x. That's the nice easy bit. The slightly harder bit is working out what comes second in each of the brackets. So we've got to look at 2 numbers here. The number before the x is going to be our addition number, and the number left at the end, which is a positive 28, is going to be our multiplying number. So we need to find 2 numbers that add together to make minus 16 and times together to make 28. Now, the only pair of numbers that times together to make a positive are 2 positive or 2 negative. Now, if we had 2 positive numbers, we can't add them together to make negative 16. So something we do know right now is that both the numbers are negative. Now, we can take that out of our mind now. We don't need to worry about the negatives. So we're looking for 2 numbers that multiply together to make 28 and add together to make 16. Okay, remember, we're not thinking about the negatives for this anymore. So we're going to write down the factors of 28. So 1 times 28 is 28, but they add together to make 29. Well, that's not correct. We need to get 16. So 2 and 14. So let's add those together. That makes 16, so that's correct. Now, we obviously know that they're minus 2 and minus 14. So it's minus 2 and minus 14. Now, a common question is, does it matter which way around it is? Well, if you think about it, 2 times 3 is 6, 3 times 2 is 6. They're both equal the same number. Okay, so it doesn't matter which way around you multiply something. So with the same with brackets, you could write x minus, in fact, why don't I write that as my answer? X minus 14, x minus 2. It doesn't matter which way around they are.
Okay, so this is quite a complicated question because there's 2 ratios and they're talking about slightly different things. We're also given an amount of one of the sides of the ratio, or one of the sides of one of the ratios, and we're asked for the amount of the first side of the ratio. So it's all a little bit complicated. But the way I'd like to start these things off is by just writing down what I know from the question. So we've got football, rugby, and we've got tennis. So football to rugby is 4 to 3, and rugby to tennis is 6 to 13. So these 2 ratios here are kind of incompatible at the moment. Got this one here, which is linking the football and the rugby, and we've got this one here, which is linking the rugby and the tennis. What I'd like to be able to do is kind of like put the 2 together and make just one ratio. So if you notice from the one I've put around a blue square or blue rectangle round, we've got the rugby as 3 parts of that, but in the green one the rugby is 6 parts of that. So what if I times both of these by 2? If I times both of them by 2, I get 8 to 6, and that actually matches the other ratio. So what I can then do, because it's the same parts of rugby, I can then say that it's 13 parts tennis. Okay, so all I'm interested in here is matching these 2 up to make these both the same. So I times the one in blue by 2 and it made it exactly the same. Now it says that 39 students picked tennis, so I need to find some way of getting the tennis to be 39. Well, that's going to be just simply timesing it by 3. And if I times that one by 3, I've got to times this one by 3, and I've got to times this one by 3. So 6 times 3 will be 18. And 8 times 3 will be 24. So we've already answered the question, because if there's 39 tennis, there's going to be 24 football. This is not the easiest question, or ratio question out there, but if you just try and link the two ratios together, then it will start to make sense and it will start to become a lot easier.
Okay, so this question's about an adult and 2 children. So we've got David Smith and 2 children. So there's 1 adult and 2 children. But the prices shown are not quite right, because there's a discount. There's a 5th off adult price and 30% off the child price. So let's work out the adult price first. So a 5th off. Well, first of all, let's work out a 5th of £70. So to work out a 5th, you can just divide 70 by 5. Now I know that 10 fives are 50 and 4 fives are 20, so that's going to be 14. So that's going to be £14 he gets off. So therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70. And then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So that's 900. That's 21 with a 0. So 900 plus 21, 210 even, 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37, take away £11.10. So if you take away 10 it's 27, take away 1 is 26, take away 10 is £25.90. Now that's for 1 child, so that's 1 child. So if I want 2 children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80. So that's going to be £51.80. Okay, I'll move down a bit. And let's do the total. So the total is going to be the adult price, which is this one here, plus the 2 children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. First thing we need to realise with this question is which transformation is it? Well, you have to go through the 4 transformations.
The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves translation. Translation. Now, translation just means we've moved it, and that's perfect because we have just moved A to B. Now, the second thing to realise is we are starting at shape A and we're going to shape B. Now, with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then, what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps, and the reason we do this with jumps is I never get the wrong answer when I do jumps. So 1, 2, I need to go 2 left, so 2 left, and let's have a think, how much up do we have to go? So 1 jump, 2, 3, 4, so 4 up. Now the way of showing translations is by using vectors, and it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, well, it's gone 4 up, so it's just a 4 there. Now here's a problem. This is how far right it's gone, but it's gone 2 left. Well, we just simply put -2 right. Now be careful, don't ever put a fraction line between the -2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. Okay, first thing to realise with this question is how you calculate the mean. The mean is the sum of all the values over the amount of the values. Now this actually creates a triangle, just like speed, distance, time triangle. Works in the same way. So we have mean here, we have the sum at the top, and the amount at the bottom. So we normally do the sum divided by the amount, but actually with this question we need to go the other way. And we need to work out the sum or the amount or whatever. Let's have a look. So it says there's 12 boys and 8 girls. So in total there's 20 children. So that's the first thing we need to realise. It says the mean number of coins for the children is 15 and the mean number of coins for the boys is 13. And we've got to work out the mean number of coins for the girls. So we know how many girls there are, which is 8, but we don't know the total amount of coins for the girls. For the boys. Okay, so where do we start? Well, it would be helpful to work out how much coins there are in total. So if I look at the triangle there, we know, so let's write down total children. I'm going to try and show my working out as I go. We know that the mean of all the children is 15. So in my triangle, I've got 15 for the mean. We know that there are 20 children in total, and we can work out the sum by timesing those together. So we're going to do 15 times 20, so there's 300 coins altogether. Okay, so now next we're going to work out, well, we're given the boys, so let's work out how many the boys have. So same triangle. We know the mean for the boys is 13, and we know that there are 12 boys. So we'll do 13 times 12, which is 156. So to work out how many girls there are, or to work out the sum of the girls, we're going to do the sum of all the children, which is 300, take away the sum of the boys, which is 156. So we'll do 300, take away 156, which is 144. So we know what the girls add up to, because if the boys add up to 156 and the total children adds up to 300, then the girls must add up to 144. But we're asked for the mean for the girls. So to work out the mean, we just go back to our standard formula we had at the start, which is this one. To work out the mean, it's the sum, which we worked out as 144, over the total, and it says there's 8 girls. So we do 144 divided by 8, which equals 18. So our answer is 18. Okay, so to convert an ordinary number into standard form, what you're going to do first of all is just write out the number. And you're going to figure out where the decimal point has to be to give us a number between 1 and 10, but not including 10. So let's try a few out. If I put the decimal point here, it's going to be 0.00341. Well, that's clearly less than 1. If I put it here, then that's going to give us 34.1. So we're a little closer, but we're not quite there. So let's remove those two because they didn't quite work out. The actual point is going to be here to make 3.41. Now that is a number between 1 and 10, so that's a big tick for us. Excellent. Okay, so we've got to find out how many times we jump between where the decimal point is now to where we want it. So 1, 2, 3, 4. So we jump 4 times. Now, to construct standard form, you put the number between 1 and 10 first. Then you just write times 10 to the power of. And in here goes the amount of jumps you needed. Okay. So to write our answer, we know that the number between 1 and 10 is 3.41. And it's always times 10. It's never divided, it's always times 10. And we've got to figure out whether it's going to be a positive 4 or a negative 4. Now there's a couple of ways of doing this. If you had to move the decimal point to the right, it's going to be a negative, and to the left it's a positive. Or an easier way of remembering it is if you've got a really small number, like a decimal, 0.0 something, then it's always going to be negative. So the answer here is going to be negative 4. Okay, so we're asked to solve these simultaneous equations, and the first thing to notice is that the coefficients of the x and the y are different. We've got 3 and 4 for the x and minus 3 and 6 for the y. So looking at that, I could times the top by 4 and the bottom by 3 to get the x's the same, but all I need to do is times the top by 2, so I'm going to do that. So 6x minus 6y equals 30. I'm just going to copy in the other equation underneath. Okay, so with simultaneous equations we work downwards. So I'm just going to highlight that. It's always useful to highlight it. And the rule is that if the matching coefficients have the same sign, we subtract. If they have different sign, we add. So looking at this, they have a different sign, so we're going to add, okay, because you've got minus 6y and positive 6y. So 6x plus 4x is 10x. Minus 6y plus 6y is going to be nothing, which is good because we need it to be nothing. And then 30 plus 10 is 40. Next, go put the lines in. And we're dividing both sides by 10. So x equals 4. And that's only half our answer. We need to substitute that into an equation. I'm going to pick the top one to find out what y is. So we've got 3 times 4 minus 3y equals 15. And I'm just going to put the lines in. So that's going to be 12 minus 3y equals 15. Now the minus 3y is going to be a problem, so what I could do is I could add 3y to both sides at this point and then take away the 15. I'm going to carry on though, so I'm going to take away 12 both sides. So we've got minus 3y equals, 3. Now at this point, if I divide both sides by minus 3, it's kind of like dividing by 3, but it gets rid of the minus on the left hand side, and it introduces a minus on the other side. So 3 divided by 3 is 1. So that's minus 1. Now at that point, if you ended up at this point and you don't quite understand what I did there, something you can do is just times both sides by -1, and what that does is it just flips the sign. So it makes the -3y a +3y and the +3 a -3. So everything switches sign, and then you can just divide by 3 both sides. Y equals -1. Whichever way you are most comfortable with. Now I can check this by putting it into the second equation, and what is it, 16 take away 6 equals 10, so we know it's right. Okay, so we asked Hannah's invested some money in the bank, and she uses a formula to work out how much money she's given after a certain amount of years. So the 2,200 here is the amount of money that she had. The N here is the number of years, and the M is the amount in her account. So the only thing that really hasn't been discussed is this number here. Now, this number here is a multiplier. So to find a multiplier, you start off with 100%, you add on the percentage increase, and then you divide by 100. So we're just going to do the other way. So we're going to start off with the multiplier. We're going to times it by 100 to get the percentage. So it's 101.1%. And then what we're going to do is just take away 100%, because that's the initial amount, and see what we've done to it. Well, we've increased it by 1.1%. So that shows a 1.1% increase. Okay, so this is quite a complicated looking question, but the most important thing is we break it down. So it says a circle is drawn inside a square. Square has a height of 12 centimeters. So the first thing to notice is it's a square. Therefore, the width is also going to be 12. And be careful to look out for that. Whenever you've got a square, they might only give you one of the dimensions. They won't always say it's a 12 by 12 square. Okay, so you've always got to assume that the other one, or you've always got to know that the other side is going to be the same. Okay, it says work out the shaded area. So the thing we notice is it's like a quarter of the square, but with the circle removed. Okay, so the first thing to do is work out the area of the square. So area of square. Okay, so the area of the square is going to be quite easy. It's going to be 12 times 12, which is 144 centimeters squared. Okay, next thing to work out is the area of the circle. Okay, now this you need to remember the formula, which is pi r squared. Okay, and that you do need to know because you're not given that in the exam. So it's going to be pi times, and now what is the radius of that circle? So the radius is halfway across the circle. Now the circle has the same height as the square, or the same diameter as the square's height. Okay, so the radius is half of that, so it's going to be 6. So it's going to be pi 6 squared. 6 squared is 36, and we write that as 36 pi. Okay, now it's an uncalculated question, or it could be in the non-calculator, it could be in either. Okay, but it does ask us to give our answer in terms of pi, so we're not going to go any further than that. We'll leave it as 36 pi. Okay, so we need to work out the area of all of the outside. Okay, so we're going to do all of the outside. Okay, including this shaded bit. Okay, so area outside circle. So I'm trying to show the examiner that I'm working out the area that I've shaded in red. So the area of that is the area of the square, which is 144, take away the area of the circle, which is 36 pi. Okay, now to work out the shaded area, which is what the question asked for. Now looking at that, we've got 4 parts. We've got this part, this part, this part, and this part, and all 4 of them are equal, and we only want one of them. Okay, so to work out the shaded area, we get our answer from before and we divide it by 4. So we're going to divide the 144 by 4, and it's dead easy to divide by 4 because you halve it, then halve it again. So half of 144, well, half of 140 is 70, half of 4 is 2, so that's going to be 72. Then half of 70, half of 72 is going to be half of 70, which is 35, half of 2, which is 1, so it's going to be, what did I say, 36. So it's 35 plus 1, which is 36. Okay, next we're going to halve the 36 pi. So we only need to halve the number before the pi, and that would have the same effect. So we're going to halve 36, or we're going to divide it by 4, but we're going to halve it first, which is 18, then halve it again, which is 9. So we need to divide each one by 4. So I've divided that by 4 to get to 36, and I've divided that by 4 to get to 9. So my answer is 36 take away 9 pi. Okay, so tree diagram question, and this one says that in bag 1 there are 3 blue counters and 4 red counters, and in bag 2 there are 4 blue counters and 3 red counters. So with tree diagrams we always start here, and we ask ourselves, well, in bag 1 we can either pick a blue or a red. Well, let's start with blue. What's the probability I pick a blue? Well, there's 3 blues and there are 3 blues and 4 reds, so 7 in total. So we move on. We've picked a blue from bag 1, so we're currently here, and we look at bag 2. Well, in bag 2 there are 4 blue counters and 7 in total. Let's go back a little bit. Let's go back to if we picked a blue in bag 1. Well, we could have picked a red in bag 2. So there are 3 reds and 7 blues. Now let's go all the way back to the start, and let's pretend we picked a red from bag 1. Let's have a think. What's the probability? Well, there's 4 red and 7 in total. And a blue from bag 2, well, that would stay the same, wouldn't it? Because there's still 4 blues and there's still 7 altogether, and there's 3 reds and 7 altogether, and that would be enough to get you full marks. Let's move on to the second question. It says work out the probability that 2 counters picked are of different colours. So let's follow the paths down. If I pick this one, so a blue and then a blue, I've ended up with a blue and a blue. Well, they're not different colours. So let's try another line. So if I pick a blue and then a red, well, that's a blue and then a red, so we want that one. Let's start going down here. So I pick a red from bag 1 and then a blue from bag 2. Well, that's the one we want. And let's try the last one. So a red from bag 1 and a red from bag 2. Well, they're not different colours. So it's these middle 2 we're interested in. It's that one and that one. Now the way of working out the probability of ending on either of those is just to write down the fractions that you passed to get there. So I passed this one, so 3 over 7, and I passed this one, so another 3 over 7. And then what you do is you times them. Now to times fractions you just times the tops times the bottoms. So 3 times 3 is 9, 7 times 7 is 49. Let's do the same with the red and then blue. So we passed a 4 over 7, and we passed another 4 over 7. And let's times them. So that's going to be 16 over 49. Now this is the problem, is we end up with 2 fractions. Well, we need one answer. So we need to find some way of combining those together. And in probability, we use the word or. It can either be that one or that one. And any time you use the word or, what you're going to do with the fractions is just add them together. Now, the beauty of this is normally you're going to end up with lovely denominators that are the same. And when the denominators are the same, all you need to do is add the numerators. So 9 plus 16 is 25, and the bottom stays the same. So it's 25 over 49. Okay, so to do this question, I'm going to start off with a number line, and I'm going to put the number given to us in the question in the middle, so 89.6. Now it says it's to the nearest tenth of a second, so what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5, and the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points, and this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side and the upper bound is on the right hand side, and the lower bound's always here and the upper bound's always here. So to answer this question, we need to be really familiar with the formula y equals mx plus c. Now y and x will constantly change, but m is what we call the gradient, and c, or plus c, is what we call the y-intercept. Okay, so we need to understand how to use that formula for this question. Now it already tells us that the gradient of the line is 3, so we can fill that in. So it's y equals 3x plus c. Nice and easy. The only thing we don't have is the y-intercept. Now the way of getting the y-intercept is substituting in the values we know. We know when x is 3, y is 17. So what I'm going to do is just put in the values. Put in the values of 3 for x and 17 for y. So it's going to be 17 equals 3 times 3 plus c. And I'm going to put my lines in so that I can solve it. So that's 17 equals 9 plus c. And we're going to take away 9 from both sides. So it's going to be 8 equals c, or just c equals 8. So looking back at this formula we had earlier, we had m but we didn't have c. Well, we now have c, which is 8. So it's y equals 3x plus 8. And you can check that by putting in the values of 3 as x and see whether you get 17. 3 times 3 is 9. 9 plus 8 is 17. Okay, so this looks like a quite simple question, however it's a little bit more complicated than it looks. It says that the sum of 3 consecutive numbers is divisible by 3, and we've got to prove it, so the working out is everything. So I'm going to name my first number x, okay, because we don't know what it is, it could be anything. But the next number will be x, same as the number before, but 1 added to it. And the next number after that is going to be the same as the first number, but 2 added to it. And it says the sum, so what we're going to do is we're going to add these 3 numbers together. So x plus x plus x is 3x. 1 plus 2 is 3. Now this hasn't proved that they're divisible by 3 yet. All I need to do now is factorise this out. So I'm going to divide each of those by 3. Now that now is proof that they are divisible by 3, because if you times any number by 3, it will be in the 3 times table. So my proof is this bit here, and I could write a sentence saying any number that I times by 3 will be divisible by 3. And on the site, that's all you need to put in.
Well, I hope you found that video useful. If you did, please click like. If you want to see more from us, including the other 2 papers, please click subscribe. We've got loads and loads of stuff on the website, onmaths.com, which you can go to here, which is completely free. But if you feel you're quite far behind in the maths, or you're not happy with the grades you're getting on onmaths.com or other mock papers you have, you can try out our premium service, which is mathseffect.co.uk. With mathseffect.co.uk, it's a small monthly fee, and you can do an annual subscription, but if you only want to do it up until November, which makes sense, you can just pay per month. And what it does is it has the whole of the Maths GCSE as a journey, and you go through each topic, mastering it one topic at a time. A lot of the students I talk to say, I really don't know where to start. Like, I keep doing Pythagoras and trigonometry over and over again, and I don't really know what else I don't know. This is a service which just covers everything. It makes sure you master and you are an expert in every topic in maths. So it's worth checking out. Loads of people have joined already, and if you haven't joined, go to the website mathseffect.co.uk or click the link in the description. That will take you straight there and you can check it out. Otherwise, thank you very much. If you want to leave a comment down below of anything you want us to cover, because we're desperate to help anyone who's being caught up in this terrible situation, which is not ideal for anyone, but equally, like, we all understand why it's happened. But if I was having to resit or having to sit for the first time in November, I would feel exactly the same as you are probably feeling. So if you want to leave any comments down below, and we might release some videos just discussing options that you have open, or whatever it might be. Otherwise, thank you very much, and I'll see you in the next video.